In this experiment, we are testing the number of turns in a coil or this loop and the voltage that is induced. So, as we begin, I'm asking you this question: what happens to the voltage if you add more coils? We've already dealt with this, we've worked with it, we've seen this here. With 4 coils and 2 coils, we see something. We already know what's going on. We have an idea about this voltage or that EMF that's being induced in that coil of wire. And what we're being asked is this is about the relationship. What is the relationship between the number of turns in a coil and this induced voltage? So what you got to do is you got to design a laboratory experiment where I want you to give me a step-by-step process of what it is that you can do if you were given a magnet, coil, a voltmeter, and what you would have to do in order to collect the data to show the relationship between the number of turns in a coil and the induced voltage. So what I have down here is some data. You're going to use this data to collect so that way we can get the voltage at these certain number of turns. So I have here Mr. Steinbach. He's a good friend of mine. He has gone through and he was able to record some of these videos. So you can look at a 10-turn, a 20-turn, 30-turn, 40-turn data set. So then what we get down here is 10, 20, 30, 40 turn. And what you're going to put in here is the average induced voltage from that laboratory experiment. And you can input the data in here into this sheet. So when you make a copy of your sheet, I can put in here, let's say my voltage was 1, 2, and then 1. That's not the real numbers, but that's numbers that I'm going to put in. So then I'm going to say that this one was 2, 3, 2, and then this one was, 3, 4, 3, and let's say this one was 5, 4, 6. Ooh. So then what we would put over into this column is your averages. So I got a 1.333, a 2.333, a 3.333, and then a 5. And so what we get is this graphical relationship shown here. This is not the graphical relationship that you're going to get. I was just putting in random numbers. But I'm going to copy this chart. I'm going to copy it, and then I'm going to paste it unlinked into my data here below. And pasting this unlinked, Control V to paste unlinked, and now I have my data in here below. So then I get asked, what is the relationship between the number of turns in a coil and this induced voltage? So this is where I'm going to remind you to check out that video where I said, what is Faraday's law? Because that's where I really try to get to this voltage and trying to talk about this, where we get electricity because we have a number of turns and that magnet go fast. So the faster magnet go, you get more electricity. The more turns you get more electricity. So we're going to be able to use that relationship in this experiment. So you got to try to tie this together. You got to try to make it so that way the relationship is fully explained. Use data from your graph. This is not the correct graph that I would use. Use the data from your graph to help support your analysis, to help support your relationship. You should be able to see in this, if I get from 1 turn, I get 1 electricity. If I double that, I get 2 turns. I should get 2 electricity. So if we now take it and step it up to voltage, if I double the number of turns, I double the voltage. So we see there is this linear relationship between the number of turns and the voltage that gets induced. So you can talk about that relationship and use your data to help support what it is that you got.